Welcome to the third part of Java video tutorial by InnoBuzz. In this chapter, we are going to talk about the operators in Java language. What are operators? Operators are some kind of special symbols that we can apply on objects and variables, which we call operands. And after the operation, we get a result, the result of the operation. Let's see the overview of this chapter. We are going to talk about the arithmetical and assignment operators, the relational operators. We are going to see the logical operators of Java language, the bitwise and bit-shift operators. We will see the type comparison operator. And at the end of the chapter, we are going to talk about the operator precedency rules as well. Let us now talk about the arithmetic and assign operators in Java language. First, let's see the assignment operator. The assignment operator is an equal sign that has two operands on both sides of the sign and gives the value on the right to the operand on the left. Note that it is important in Java language we cannot compare values with this operator. It's going to be the two equal signs that we are going to see later. So if you only use one equal sign, then it is going to be the assignment operator. There are more complex assignment operators that are using also arithmetic or bitwise operators combined. We are going to see them a little bit later in this chapter as well. The arithmetic operators are the following: the addition operator, the subtraction operator, the multiplication operator, the division operator. Now these four can be well known from mathematical classes. The remainder operator is a little bit more difficult. It gives us the remainder of a division. The left side is going to be the number we make the division on. The right side we make the division with, and we get the remainder of the division. I'm going to show it in practice. The increment operator and the decrement operator can be used in prefix and postfix ways to change the value of the variable with 1, to increment or decrement it. The relational operators also have two operands on their left and right side, and they are going to tell us about the relation between these two operands. The first is the equality operator that I've already talked about. This stands up two equal signs, and this tells if the two operands are equal to each other or not. Note that all relation operators give us a result of a logical value, true or false. So this gives us true if the two operands are equal to each other. The not equal operator is the opposite of this. This gives us true if the two operands are not equal to each other, and false if they are equal. The greater than operator is true when the first operand is greater than the other. The greater than or equal is true when the first operand is greater or equals to the other one. The less than and less than or equal work similar to these. Now let's continue on with the logical operators. These operators perform logical operations. They set up conditions, and the result is also a logical value. The conditional AND operator. It stands out of two AND signs, and it gives true if the two operands on the two sides are true in the same time. The conditional OR operator, which stands of two vertical bars, has got also two operand on the two sides, and if one of them is true, then it gives true, and of course if both of them is true, then it also gives true. The logical complement operator is a prefix operator, so the operand stands after it. This operator gives us the complement of the logical operand that is after it. So if the value of the operand was true, we get false. If it was false, we get true. The ternary operator is a three-operand operator, which we are going to talk about in the next chapter. We are going to do some practice on operators now. I have set up a class here which contains already all the arithmetical operators in a system of print line. I have declared two operands here, operand 1 and operand 2. I'm doing all the operators with them. The first is 8, the second is set to 5. Just simple integers. Here I add them, here I subtract them, multiply, make the division, the remainder operator. We are going to talk about them, the incrementing, decrementing. Okay, just run it first and we will see the result. Okay, here we have the results. There are the two numbers added, it's okay. What is important about this? As we can see that we have two plus signs here. One of them adds the two numbers. This is the arithmetical operator that we were talking about. But there is an extra plus, but it is in every row, as you can see. There is a specialty of the plus operator that it can not just only add numbers, for example, like these integers, but it can also add strings, and this is but in this case it's called concatenating. So put together two strings, as we can see here, the two operators, this string, and also it is also becoming a string, the result of this plus operator. So as you can see that we also have the subtracting here, and we have got the result here. Okay, we have the multiplication here, we have a division here, but it's funny because the result is 1, so it's a whole number. Yes, well, because it's there was typecasting to integer, so we didn't get the float ones. We should have used floats. It's no problem. If I, for example, cast it to float like this, we are going to get the right result. Yeah, it's 1.6 now, because when all the operators, and this is an important thing, are behaving depending to the operands. If we have, for example, this division operator and the two operands are integer, then it's going to be an integer division which is going to give us an integer. So we lose the part that is not the whole number. So we lose the part after the decimal point. But if one of them is float, then the operator acts like a float division. That's what we have seen. All right. The other thing is the remainder operator here. We have 8 and 5, and we make a division to 8 by 5, and we have the remainder here, which is 3, because there is 1 times the 5 in the 8, and the left is 3. We can use it in many parts of our programs. This next thing is the incremental operator, which I used this time as a postfix operator. This, you can see that it's after the operand this time. I use operand 1, and this is after it. So as you can see, the result here is 8, but the operand 1 is 8, so it didn't change the value. Well, this is interesting, but it's because it's a postfix operator. So if I put the plus here, then I will get the same result. So it's the same thing as I wrote here, operand 1, and after it I would write that operand 1 plus. It's the same thing. So just like this, it would be the same thing, because the Java this way only increments it after our statement. If I put it before, then he does the operation before evaluating the statement. That is what we can see here. But I made a little mistake, because I have written operator 2 here, operand 2, but I forgot to change it here. Yeah, so that's why we get the same result, because here it incremented the operand 1, and here it decremented it, so we got the same result. It's no problem, it's working all right, but I wanted to write 2 here. Just to be able to show. Yeah, so we have got 4 here, and it was 5. So now first the decrementation was done, and after it was the whole sentence, the whole statement evaluated. Now this is it. What else have we got here? I have cheated a little bit and wrote some notes for myself, so I won't forget what we have to check. These are the conditional operators. As I told you, this is when we have 1 equal, it's the value, and the value goes into the variable. So it's the way we give the values to the variables. But if we have 2 equals, and I'm going to check it here, for example, or let's make new ones. Just so I copy it quickly. Okay, so we are going to do it step by step. If we have this, then it's producing it's a condition from now, and there is not going to be any arithmetical operations. This is only kind of Boolean type or conditional type of operation, and we are going to get true or false now. Just check it. False. It says false because operand 1 and operand 2 are not equal to each other, and that is true. Now quickly we are going to do a few of these. Okay, when they're not equal, for example, and not equal here as well, no, this, then we have the greater equal. Okay, smaller, we don't have too many, luckily. Yeah, smaller or equal, no, like this. Okay, no, okay, and what's the, no, this was it for now. And see the result. Okay, here we have all the operators: false, true, 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 false, false. Well, it depends on what we are doing, of course. If we have, yeah, these two operations are going to give the opposite of each other. So if this is true, this is false. If this is false, if this is true, because this is the equal operator and this is the not equal, so they must give the opposite. The two operands are not equal to each other, so it's true, because one of them is 4 now at the moment and the other is 8. Okay, so this is bigger. The first is bigger. It's all right. Is it bigger or equal? Yeah, it's also true. We are going to play with that as well. It's the two are false, but they can give a different value. So if I, for example, change the value of operand 1 to, what was it? Operand 1 was 9 or something. Well, that it's no matter. It's 4 now. The other, let's make it 4. Yes. Yeah, we can see that the first is true now. The second is false, of course, the opposite. And for example, now they are equal to each other. So the first is not bigger than the other, so it's false, but it's bigger or equal because they are equal. So we can see the difference between the equal, bigger or equal, and the bigger and the smaller one, and smaller or equal here. That's it. Just a little break now. I don't know if I have mentioned about these comments. As you can see, there are some program parts here that are hardly be seen because they are gray. This means that they are not highlighted. These are comments. What are comments? Comments are part of programs, program text that are not for the Java compiler. The Java compiler doesn't take care of them, so the compiler just cuts them out before compiling. Why are these here? These are here for the programmers. These are called comments. Programmers can write notes or anything for themselves. I can say, for example, I make a note here. These are the arithmetical operators. And right here, these are the conditional operators. That this way, later, if we get back to our program code, we can see that, for example, what part stands for what, which method is doing what we wanted to see, or we forget what is one of the parts doing. So we just make a short description there. Or sometimes we use it like if we don't need a program part anymore to be working, we can comment it out. But it's gonna be still in the code, so maybe later if we want to use them again, it's gonna be there, but it will not be compiled. There are two kinds of commenting. This is the one-line commenting way, when we use the slashes, double slash, and the rest of the line is going to be comment. Or we can use a slash and a star, and then it's a multiple line commenting, and we have to end it with the opposite, so star and slash. Now we cannot see that the following parts are going to be highlighted again. So it only cuts out the part that is inside these two. This way we can see, for example, if we don't want these, we can just simply comment them out this way. And some more about highlighting. You can see that all the words are with some of the words are with different colors. Some are with black, some are with green. Some packages, the blue ones are the keywords. The strings are red. So this is called syntax highlighting. When we have a program editor, program text editor, like the NetBeans IDE has a good text editor, which knows the different programming languages. Then we have our file extension. It's our file's extension is Java. So the NetBeans knows, and our editor knows, that it's a Java file, and knows all the syntax parameters and rules of Java language, and makes the syntax highlighting so we can see in our programs what we have got. And also knows the packages. If you have this system package, for example, we get a dot here, and it shows us all the possibilities that there are, or the methods and members, but we are going to talk about that later. Now, to get back to our program, we should use also the logical operators quickly. Yes, logical operators like well, they can be applied for logical types, so not really for integers. I make some booleans here. Boolean op1, I call it op1, true. Boolean op2, false. So this way we can show it simply. You have the and here. What's the problem? I have to change the names, so it cannot be applied as I told to integers. Oh, up to, and what was that? Negating. This is a unary operator, so I only need one. Don't even need this. Okay, this is it. I save it and run it. Okay. Well, I should have commented out the others because it's a little bit messy, but we can see what we want. These three lines. The operator 1 and operator 2 is false. One of them is true, the other is false. If we say that and, it's true when both sides are true. So now it's false. It's gonna give a false result because one of them is false. But the or gives us the true, because for the or it is enough that one of the operands is true. It only gives us false when both of the operands are false. And this is the complementary operator. This will give us the opposite, the complement of the operand. So if op1 was true, we got false here. Just make a very quick changes to and made the commenting thing. Yes, it's so easy to cut program parts like this out for a while. Now we see that the first two lines are true. The and is true now because both of them is true. But op1 is false because it was true. If I change it to both of them to false, you will see what's here. Okay, then it's false. Also the or is false, which was true before. Every time, and it's true. The complement is true. Okay. We are going to create much more complicated program codes later, but now we don't know enough about the programming still to create them. What I am showing you is that with the equal operator we can do some more tricks. So the assignment can be combined with the arithmetical operators, for example. So I say I can do it this, for example, this plus plus thing here. I can do like operand 1 plus equals to 1. This is the same thing, but mostly with 1 we use the plus plus, but if I want to add 8, then it's very simple. So it means operand equals to operand, the same thing, plus 8. So it adds 8 and changes the value to that. I cut this out this time. And we can see that operand 1, I didn't even write it out. It's funny. I write operand 2 here. This way we are going to see. Yeah, it's 12 now. So first it was 5. We didn't change the value. Then it became 13 here, adding 8, and it's 12 because it's 1 less. This is, but we can use this with as well with minus or the multiplication, the division, and also we can use the remainder here simply. Yeah, now we get a bigger 39 because it was 40. 5, 8 times 5. Okay. Now these are the most common things about these that we are going to use later in our program parts. The bitwise and bit-shift operators are less frequently used nowadays, as they are not really easy to read within the code. These operators can be applied on integers and longs, but the operators work with the binary representation of these numbers. So if you want to understand how they work, you have to think of the binary representation of the numbers. Binary representation stands out of only zeros and ones. The bitwise complement operator is a prefix operator, and the operand that stands after it is going to be changed at every bit. Wherever it has got a 0, it's going to be a 1, and wherever it has got a 1, it is going to be a 0 after it. So it changes every bit. The signed left shift operator has 2 operands, one in the left and one in the right, and it shifts the bits of the left element to the left with the number of positions that is given in the right operand. The signed right shift operator does the opposite. It shifts the bits of the left operand to the right with the positions that are given in the right operand. The unsigned right shift operator does the same thing with unsigned values. The bitwise AND operator has also got 2 operands, the left and the right, and the result of the operation is going to be a number which has got ones in the positions, in the bit positions, where both of the operands have 1. And all the other places we will get 0. The bitwise exclusive OR operator gives us 1 if both bits are different in the corresponding position. So if we have got in the same position of the two operands 1, then we get 0. If we have it in the same position in both operands, we get 0, then we will get 0. And if there is one of them 1 and the other is 0 at the same position, then we will get 1. The bitwise inclusive OR operator works differently because it gives us 1 in a position where any of the bits of the operands is 1. So this only gives us 0 when both of the operands have 0 at the same bit position. We also need to talk about the type comparison operator. This is the instance of operator. With this one, we can check whether an object is an instance of a class or not. This also gives us a logical value, true or false. And it looks like this. We have an object name or an object variable, instance of class name. So the two operands are on the two sides. The class name is on the right, and the result is going to be true if this object is the instance of the class. Let us now do some practice on the bitwise and bitshift operators. I've already set up a program part here to show you this. As I've already mentioned, we need some special ways to be able to show it, the binary representation of the numbers, that is, we need. We have two integers here, simple integers, but when we apply these operators on them, it's better to use the binary representation when we are printing them out. So first I just simply show them how they look, just simply the numbers without any operand, without using any operators, just the numbers, how they look in binary way. These are the two numbers in the binary representation. The 8 is 1000, the 15 is 11111. Well, we don't really have time here to talk about the binary numbers and representing numbers in the binary way. So I hope you have all learned something about this in school. As you can see, the 111 gives us the 15. Just a very short calculation. It's like this bit is gives us 8, so it's a fourth. It's 8. Then we add 4, and then 2, and then 1. So this is the 15, for example. The 8 is just only 1 at the fourth bit, which gives us an 8. Now we are going to apply the operators on these. Yeah, I save it and run, and I'm going to talk about the results. The first is a unary operator, which gives us the complement, the bitwise complement. As you can see, of operand 1, so this number, the 8, as you can see that the last 4 digits are the opposite of these. So it's 1 0 0 0, it's 0 1 1 1, and all the left is just ones. How did these ones get here? They also used to be the complement, so they used to be zeros here, but we cannot see them because just like in decimal numbers, we don't write zeros before the numbers. But we have as much numbers here as the range of the integer. So these were the zeros here. They become ones. The 1 became 0. And all the others also became 1. When we do the left shift on operand 1 by 2, and we get this result 1 and 5 zeros. We had 3 zeros here. Now 2 extra zeros were added because we shifted it with 2. And the 1 came 2 with the left, to the left. Just to make it a little bit more interesting, so shifting left by 2 is the same thing as if we multiplied it by 4. Shifting left by 1 is multiplying by 2. Shifting to the right is the next. We apply it on operand 2. This is 1 1 1 1 1, and we get only 1 ones because we shifted it to the right by 3. So this one came to the right by 3 steps, 3 places, and all these other ones have been thrown away. Shifting to the right is a division by 8. And if we make a division, as you can see, if we make a division of 15 by 8, then we got 1, because there is only one time. So it's not divisible with the 8. So the left is thrown away this time, this way. The unsigned shift to the right by 1 gives us the result that this 1 came 1 to the right. So this way is the same thing as if we made a division by 2 on it. It can be applied on unsigned numbers. The bitwise AND operator is also very interesting because we can do some special things with it. We can use it with these 2 operands, and the result here, it came from these 2 operands, and we have only one here at the position where both of the numbers had 1. This is only the first position, as we can see. The bitwise exclusive OR will give us 1 1 1. What is this 1 1 1? It only gives us 1 at the positions where the 2 numbers are different from each other. So as we can see on these 3 positions, they are different. 0 0 0, it's 1 1 1. So we got 3 ones here. This became 0 because they are both ones. So it also disappeared because the 0 in the left, we don't write it out. So this way we got this result. And if we use the inclusive OR, it has a different rule. It gives us 1 at the places, the positions where one of the numbers has 1. And as we can see, at all positions there is at least one of the operands that have 1. So then we have all the 1s here. Now that's about the bitwise operators. What can they be used for? Well, they can be used for more special things. Sometimes they use them for flagging bits. It's like when we use an integer, then we can use all the bits of an integer to be, for example, a flag, which can be 0 or 1, and then we can read it out, all the bits, and we can save lots of space with that, because on an integer we can store 32 flags in just one integer, for example. With the bitwise AND we can do masking. Masking is when one of the operands is called a mask. The mask has got 1s only in the bits that we want to use from the other operand. So if we have got a number that is called a mask and make a bitwise AND with another operand, then we will get precisely that part of the operand that we have the mask with the 1s. Now this is a little bit more complicated. That's about the bitwise operators. We have to talk about the operator precedency now. What is the precedency in the Java language? When we are talking about operators, we have to know that the expressions that are standing out of operands and operators are going to be evaluated by the Java compiler. But what happens if there are more than one operators in the same expression, in the same program line, or in the same statement? We have multiply operators. There has to be some rules that are going to be applied on these when the Java compiler evaluates the code. And these are the precedency rules. The operator which is at the highest precedency is going to be evaluated first, and the others which have lower precedency are going to be evaluated later on. We have an order here. The postfix, incremental and decremental operator has the highest precedency. The prefix ones and the adding and the bitwise complement operator and the logical complement operator, the arithmetical multiplying, division and remainder operator, the adding and subtracting operator, the bitwise shift operators, the smaller, greater, smaller or equals, greater than equals, and instance of operators, the equals and not equals operator, the bitwise AND, the bitwise exclusive OR, the bitwise inclusive OR, the logical AND, the logical OR, the ternary operator, and at the end, all the assignment operators that are stand out of the equal sign and one of the arithmetical operators or one of the bitwise operators. We are going to talk about the operator precedences now. When we are making programs in practice, this part is really very important to know, because we have to know what our program is doing, what our program is going to do after the compilation, how it is going to work. And if we know the precedency of the operators in our statements. This can be one of the most important things, because the expressions and statements that we are building use many operators, and it is important to see in which order they are going to be evaluated. This is a very simple, very short example that I'm going to say here. I just make an integer and say 7 plus 8 multiplied by 3. And let's see system.out.println. Println A. So I'm going to write the value of A. What will we have? Well, this is not really complicated. After the mathematical classes, secondary school, I think we know that it's gonna be 31, I think. And it is it. Everyone knows, or I think most of us knows, that how this works. I didn't even tell anything about the precedences. It's because we all know a little bit about them. We have learned in mathematics that first we make the multiplication after we add the other number. The addition is the second, and then we give the value to A. So we already have 3 operators here in this small, very easy sentence that are evaluated in an order that is given by the precedency order. The strongest is the multiplication of these. After that comes the addition, and then this evaluation. So if I would use brackets, I could write something like this. But I don't have to use them only for myself to show that how it works. It's the same thing. The same thing happens. For the Java compiler, it's no difference. Of course, if I want to change this evaluation order, I know that the precedency is this. This is going to happen first, this multiplication, but I don't want that. I want to change that order. I use the brackets here, and then I get 45. So this was a very simple way to show it, but I'm going to show it that, for example, if we create booleans, just example here, I say that true and false and or true, and write out the example. Sorry. So this is a simple boolean. I created a boolean. I use different operators. I use the and the or, for example. And well, what is going to happen now? I think we are going to get true now, of course. Example is true. How did it happen? It happened because the first there was the end evaluated, and then the or. So if I use brackets to show that, I should write it this way. There was the true and false, which is false anyway, and then I said or true. Well, maybe this is not very easy to see, and then this value that came here from here we give to the example, which is a boolean, and we wrote it out like that. But if what happens if I change, I run it like this, we get the same result. Yeah. What happens if I change this to false? We will get false, because one of the parts, both of the parts were false. Yeah. Maybe it's not very easy to see it this way, but it's really important to know how they are going to be evaluated, in what order, because it's not the same thing. It's just I can do it like I put the brackets here, and a total different thing is going to happen. Well, it's going to be false anyway this way, but it's false or false. Well, it's not false. I say true. This way it's going to be true. So we can change the evaluation order, but we have to know what the precedence is to see how it works. Yeah. Okay. Let's combine these things. I have an integer here, which I simplify a little bit, just 7. An integer b, which is 5, and an integer c, which is going to be 3. And we I want to show that these truths and false are some kind of conditions. For example, I can say that A is smaller than B, or B is smaller than C. But I can say B is smaller than C plus C, for example, as well. And C equals to A multiplied by 4. Now this looks more like more complicated, but during programming we have to know how this is going to be evaluated. So if we are not sure about the evaluation order, about the precedency of these, we have to use the brackets or something that we want to make sure that what the order is. Now we say that I'm going to show you with the brackets. Okay, I run it first like this. We get a false, but then we arrange it a little bit so we can see what's happening. The strongest thing is this plus plus. It has the highest precedency. and then the multiplication is going to be evaluated, and then we are going to have this part, the less than part, and the other less than part, and then this equals, and then the end, and at the end of it we are going to evaluate this OR. So this stands out of two expressions. One of them is a smaller than b, the other is this. But this inside stands out of two, and these two are the following. B is smaller than plus plus C, and C equals to A multiplied by 4. So this way it starts to be easier to see, for us to see what is going to happen. Well, we say there is an OR. The major thing is the OR. So if I say A is smaller than B, well, A is 7, and it's not smaller than B. So this is false. This part is false. So if this part is also false, then we will get a false. Plus plus C, it's 3. If we add 1, it's 4. It's not bigger than B, so this is false. This part is false. And I really don't have to work further because we have an AND here. So the first part of the AND, the first operand, is false. It's no matter what this is, if it is true or false, this AND is going to be false. And this part was also false. And it's connected with this OR, so it's going to be false. Well, these examples and these expressions can be very complicated sometimes. But when we are writing programs, it is good to make some practice in these. So it's the best to know the precedences, which is evaluated up to the other. And if we are not sure, then use brackets. So this way we can explicitly tell the compiler and show to ourselves as well how it works indeed.